I'd like to introduce Ravi, who's going to help us understand IMSI privacy. Thank you.
Thanks. So my name is Ravi Shankar Burgaonkar, and my co-speaker Swapnil, he's unfortunately not able to hear due to in time he didn't get visa. So I had to continue the talk myself. So I will also cover his part for the presentation. So this talk is about understanding IMSI privacy. Actually, the title which I propose while submitting for a black hat is what about how to turn your phone into a IMSI catcher. Also, how to turn your phone into IMSI catcher detector device. But due to some concern, I had to change the title. So basically, I will try to cover what are the unresolved privacy issues we have in mobile space, particularly about, are you really sure that the last call you made, whether it was encrypted or was it authenticated? Can somebody intercept your call besides the legal entities or maybe illegal entities? So still, we really cannot be sure. So we know 2 pointers. One is the IMSI catchers, one is the silent SMS. There's many police agencies or maybe other entities use those kind of things. So I will just highlight those points, then come back to what was the motivation behind developing this tool, why I developed this tool, which is a privacy framework which works on Android. Then I will show you some of the use cases of this tool. How you can install it on your phone and what kind of features it shows you. And I will also show you some real live demos, how it works. Unfortunately, I had to skip some demos due to some issues. But I will show what are the possible demos and some real screenshots which I collected from Germany and some other European countries. And some future works, what we're going to do with this framework. Let's look at the first about what are the unresolved privacy issues. Okay, so I mean, everybody knows that operating system providers, whether it's a Google, BlackBerry, iOS guys, even the Firefox new team is coming, they're claiming that they have the most secure phone, they care about the user's privacy very seriously, they try to protect all your user data, all your mobile communications. Correct? Even the manufacturers, they do also different things to protect you, like stolen mobile phones, or how to wipe your data securely, all those things. And at the other hand, we have a mobile network operators. They try to say that, okay, our communication is secure, we follow all the standards and all those things. Correct. Still, also there are some researchers like us, some research labs of different companies try to protect, try to improvise the security of GSM, 3G, even the Android OS or Google. So there are different parties try to improve the mobile security. The devices are good, but still there is a problem with the cellular networks. Why? Because as a user, you travel everywhere. I mean, you are not always in a single city. So as you change the city, the configurations of every base station changes. So how do you really see that, whether you are having the same kind of security level in US or maybe when you go to Kenya or some other country? So when you're roaming, what really happens with your data? So this is really a serious concern because nobody follows the single protocol or some same standard. This is still a problem. But the main concern is, okay, everything is secure. Your device is secure. Google says nobody can root your device and everything. But if there is a targeted attack on your mobile phone, how do you protect? There is no solution. So who does the targeted attack? We know this is one part is IMSI catchers, which are basically, you have seen some Hollywood movies, FBI van comes and they intercept your call, fancy, they record all the audio and everything. So these are the targeted attacks. How they really do those attacks? I mean, they are allowed to do if they have a court warrant, but without a court warrant, how they do? Because if they have a court warrant, they can go to the operator and ask, hey, give me all the data, and then they can legally see all the data traffic. But without a court warrant, they have to do some targeted attacks, and only way is IMSI catcher. Either they're allowed to do or they're not allowed to do. So this is illegal or legal. I'm not going to discussing about that point and what are the methods of doing that. So these are some of the interesting questions about the mobile security. What happens if the target attacks? So let's look just a brief introduction about what are these targeted attacks. IMSI catcher, or compromising phone. I try to divide into two categories. First is IMSI catchers, which are actually often used by the FBI or the police agencies. And these exploits the weaknesses of GSM, basically, 3G. Some manufacturers claim that they also exploit 3G networks. And last is, main goal is to track you in some area, basically location tracking or interception. Now, this was the Snowden who leaked this information. You see this point. So this is a 3G GSM tactical interception device. This is from a Gamma technology company from Germany. And they claim they have the both solution for 3G and GSM. There was one more company called Cambridge Wireless, which is in UK. They proposed they have the device of your BlackBerry phone size. Basically, it's a femtocell, a tiny femtocell which can be converted into an IMSI catcher box. So basically, this also works for 3G. Technologically, it should also work for LTE. So it doesn't mean that if you're using LTE phone, nobody can attack you. So basically, it's still possible. And there is one more point about compromising phone. Okay, I don't want to use IMSI catcher, but I want to have a data from some guy. How do I do? So there is a tool called Pegasus. I think it's an Israeli name or something. I'm sorry, I'm not good at pronouncing. So what basically this software does, so this is the text from their manual. It says the system introduces a powerful and unique monitoring tool of this name, which is remote and stealth. So they claim that they have some exploit that they can send you a firmware on your device, and this is the compromised firmware which can send silently all the data, whatever they want, back to their server. Now, how do they do? Do they have some OTA exploit? I mean, how they exploit the OTA protocol? We don't know. So this is one more method they do actually. Even there was some article about this tool, which is done by some Israeli company, and this company is brought by now some US company, if I'm correct. They can also enable the webcam by sending some remote command. I don't know how true, but if you Google, definitely you will get more information about this tool. Now, point is how they really do those targeted attacks. So this was the first part about targeted attacks. The second things, what are the unsolved security questions, and what was the motivation behind me to come to this tool? First is, how do you really verify that the last call you received, or maybe you made, was it encrypted or authenticated? Encrypted means, was it using A53, which is so far the best encryption algorithm using GSM, or it was A51? I mean, personally, take any phone, your iPhone currently 6, 5, anyone, take a Google Nexus or any phone. Nobody shows any indication was your last call or the current call was secure. This is still unsolved issues. I will come back to this problem, why it's not fixed. How do you verify? Is someone tracking you on your phone? You might have heard of fancy stories. How do you want to protect yourself? Never use mobile phone. Or you might have seen some Hollywood movies. If he's in a problem, he throw out first his mobile phone and SIM card, and then nobody can track him. But still, how do you verify yourself that nobody is tracking you? No solution. I mean, of course, government is allowed to do that, but without any government. Can someone listen to your call or SMS? Can they intercept over the air? Still, besides legal entities, of course. Are you a victim of IMSI catcher attack? What I already shown you some targeted attacks. How do you verify whether your phone was compromised in this fashion? Or maybe there are some IMSI catcher devices are tracking you or trying to intercept you. So how do you do that? Question. And lastly, is your mobile handset or manufacturer or the operator using up-to-date encryption standard? After the Snowden stories, we know what are the capabilities of NSA or maybe other agencies that they can decrypt A51. Of course, it's publicly known that A51 also can be decrypted using some standard methods. But has all the, I mean, not a single operator, but have all the operators have upgraded their systems to A53 or whatever the current standard? How do you do that? So these are some unsolved questions. And lastly, just to coming back to my motivation, ecosystem problem. What is ecosystem problem? The first one, the 3GPP standard for the mobile communication says that every mobile handset who manufacturers has to have one feature which is called ciphering indicator. I don't know you guys seeing. So this is from the standardization document. I capture a snapshot which says that this is a mandatory feature. If you are a manufacturer of handsets, you have to implement this feature on your device. This used to be a fact in old days when old Nokia phones and some other devices used to follow this protocol. You see a screenshot. Actually, this is the old Nokia phone. When you try to make a call, it tells you the ciphering not provided by your operator for this transmission. Nowadays, nobody follows this protocol to show you that the current network is not secure. Second thing is there is no API for any OS. Now, I don't know, this is the problem of baseband providers, that they don't provide API or some parameters there. I have no idea. So for Android, there is no API for that. Of course, first, the API has to be opened for the developers by, of course, the OS provider. But OS provider can also claim, okay, we don't have any data from the baseband, so we don't know exactly how to do that. So I have no question, I have no answer, or I have no insights for that. And you see there is one link already. Some developers asked Google, why don't you enable this API so that we can do on Android? But still it's on low priority. It has not been updated. And the last thing is the best solution that either you are a victim of some compromise attack or maybe IMSI catcher. You know that all the operator always has to verify whether you have money to make a call. So, for example, you make a call right now, they have to verify whether you have a balance to make a call. So they check your credentials, right? And then they're allowed to make a call. And this call gonna be bill you. So you will have some dollar or something for that call. So the best solution, check your balance right now. So if you're using a prepaid card, and last time you made a call, and if this call is free, it means that all the IMSI catchers call are almost free actually, because they never bill you, because these are not real operator. These are the IMSI catchers. So the best solution, check your monthly bill. But nowadays, everything is flat rate. You really don't, it's up to you. If you have a prepaid card, you can check everything. But this is the best way to secure yourself. But still, due to a flat rate or maybe other things, nobody monitor these things actually. This is pretty simple way to protect yourself. So to solve all the questions, when I was doing my own research on other different problems, I thought, why not have a single tool on a phone which can try to solve all this problem for me? And that's what we designed this Darshak framework, which is called Darshak name. So let me just give a motivation for this tool. So this tool is only designed as a research platform to collect the GSM and 3G network parameters, some security parameters. I know once we finish the slide, many people will think that this tool can be turned as an IMSI catcher itself. So it might have some bad consequences. So I don't want to point that. So the only motivation for this tool is as a research platform. And second thing is easy to use for any user. I know there were some tools, for example, GSM map from Carsten Knoll, or maybe some other tools from Osmocon. Maybe you can use those tools and monitor all those things, but you need some dedicated equipment. You need to understand many things to analyze those things. But as an end user, it's not possible for you. So second motivation is any user can just simply install this app and see all those parameters and can verify those things. So what is this framework? So first, it displays the security capabilities of your mobile network operator. So if you on the right side, if you look, so this is just a highlight. So last time I made a call on a GSM, I sent SMS. So was it really encrypted? It gives me a legend, green symbol. It was really authenticated. It was encrypted. This was outgoing call. The second is then we have this exclamation, this mark is about the silent SMS. If somebody sent me silent SMS, so it shows all the legend. And this framework, we modified in a different fashions to collect the data. So it automatically logs the critical data in a database, notifies the user at the right time based on the collected data. For example, in the whole day, wherever you travel from your office to work, it collects all the data of different base stations you travel along 50 miles or whatever it is. It notifies you based on the intelligence what we have put into the program, small algorithm. It collects more data, asks the user if you really want to upload the data to our server, because the problem of GSM is to have more data to solve this IMSI catcher. So I will come back to point later. And the security features we have, it supports for GSM and 3G networks for every incoming and outgoing call. Then it captures the silent SMS and notifies the user. So you guys might know that there is one more project actually on Android IMSI catcher detector, so which is started like last year or something. Now they also claim that they also detect silent SMS, but personally I used their tool and I also tried actually. So, but it didn't detect, but maybe they are trying to improve. So I will try to tell what is the difference exactly what I'm doing and what they are doing. And displays suspicious activities, so based on the different criteria. I will come back to point also later. And it also alerts. For example, you go to some other country, you try to make a call, and if it's not encrypted at all, for example, A50, it immediately pings you, hey, you are roaming right now, we know that, and there is no encryption used by your operator, so it may be a French operator or it may be a German operator. So this kind of alerts, it gives you right away. So you can decide whether you want to use a VoIP. Of course, it depends how you care about your privacy. So what are the technical details? There are a little bit about technical details. It's running on Intel baseband devices. Currently supports Samsung S3 and S2 and it's based on X-Goldmon concept. So there was one German researcher who developed a tool, X-Goldmon, which especially supports for Intel baseband due to some leaked data. So it's possible to enable some features there. And after that, GSM map, which is the Carsten Knowles Research Lab in Germany, they also developed a tool last year for a GSM map, which allows you to make some calls and you upload those calls to collect the GSM map about different operators in the world to show what are the security. So we use some of their methods to produce some interesting data. So thanks to GSM map also. Of course, the device needs to be rooted. If you have a Samsung Galaxy S3 or S2, the device needs to be rooted. The key feature is it notifies the sender's number for silent SMS. This is essential because what the Android IMSI catcher guide said, it's trivial to show you the sender's number because this log never goes beyond the baseband. So the number always stays in the baseband. Until you have some access to the baseband logs or maybe some features, you cannot display who sent you this silent SMS. So this is one more parameter we added. Then some technical parameter information, it shows you whether it's showing you A50 algorithm, A51, A53. These are the encryption algorithms used in GSM network. I hope you guys are familiar, but I try to skip. I have added some reference later. And then current TIMSI after every event. The TIMSI, actually every SIM card has a IMSI, which is the International Mobile Subscriber Identity. And only first time it is used, and after that, you are identified by a TIMSI. One of the goals of this tool is it always tells you when your TIMSI is changed. So basically, you can see how often your operator change your TIMSI, because this is a critical thing not to locate you or try to be anonymous on the OTA interface. So we keep track of TIMSI always. And also it displays random number and authentication token. I mean, this is not useful for any user actually, but for a research platform, these are the parameters essential for us to see what are the different configurations has been done by your operator, because these tools give us freedom to collect all this data, the random number authentication token, how random they are. Maybe they don't change often, maybe they don't update your TIMSI. So all these parameters we collect on that one. Methodology is pretty simple. As I said, we fork some of the GSM map source code already, what they have released. So basically, it gets the baseband log, first of all. Then we scan for some of the parameters, what are essential for us to detect, like silent SMS, paging requests, system type info for the base station. Then we also collect 2G and 3G security parameters. And this loop is always goes per 1 minute. So after 1 minute, this loop repeats itself and we collect the data as it is and record all those data. Of course, we're going to release also the source code. If you are interested, you can change the settings to 30 seconds and you can collect more data as you want. So it can be pretty active and fast depending on how do you want to do it. And of course, then we notify to the user all the incoming and outgoing event. The interesting fact is, okay, so before I tell you all the application use cases, what we are doing with it, I will just go a little bit, give a background about GSM, what we know. I'm not going to explain in too detail, but just to tell what are the essential parameters when you use this toolkit, this tool or app to understand. So we know in GSM, you have a mobile phone and a base station. Forget about the back-end part. So what happens over there? What are the problems we know? First is there is no mutual authentication between two entities. We know that. So the fake base station or man-in-the-middle attacks are possible. Known fact. I mean, I'm not telling something new here, just to give a brief introduction. We know there are the weak algorithms. A52 is completely broken. A51 can be decrypted. Even the NSA slide deck shows they have a capability, or maybe other agencies. The problem is also base station decides when to do encryption, and that is the thing actually all the IMSI catchers work, because they force you to not to use encryption for your phone. We know that, so these are the downgrading attacks which are possible. Then the plain text over there, IMSIs and TIMSIs are always sent plain text over there. Of course, this is not a flaw, but this allows you to track somehow, but without this, your system will not work. There is no authentication for IMEI, which is used for your mobile device. If you listen yesterday's talk where they exploited the cellular feature on global scale, actually the vulnerability, they were using IMEI as a code. So you see IMEI is always in a plain text, or it was never authenticated. So actually if you have a proper equipment, anybody can track your IMEI number or capture your IMEI pretty easily. And the last is local regulations, which makes GSM security pretty bad. Because no upgrade, not all operators using A53 algorithms, still some of the operators using A51. When I tested my network here, T-Mobile, USA, AT&T, here still using A51. Weak algorithms. So we know GSM is badly broken, right? And it has been proven by the various researchers. But has it fixed and upgraded by your operator as per the GSMA guidelines? Some operators really do care, some not. And if you have authentication, then if you don't do authentication, then we have a problem about mobile originated, like when you make a call, or mobile terminated when somebody makes you a call. And some of the researchers, for example, from my group, Nico already had a paper, they already mentioned that if your mobile terminated call are not secure, then somebody can hijack your SMS, so they can take your SMS for a GSM network. So it's true. So these are the essential parameters. And the encryption, whether it's using A51 and A53. So the threat model for the use case I'm going to show you is not the government, because there is already lawful interception. Because all the operators stores your data, SMS, everything for depending on 6 months to 2 years, depending on every country, depending on the local regulation. So my threat model for the tool is, of course, other illegal entities, which try to capture your data or not. So let's go about the use cases. So I will show you how this tool works and what are the things I'm going to capture. The first thing is GSM and 3G security indicators. So every time you make a call after installing this app, like any radio event, radio is pretty essential. I will come back to this point. So you see all the event, like incoming call, outgoing call, SMS. Now you see this point. Actually, these are the logs from Germany. I wanted to create here, but unfortunately, I was not able to show from US networks. So this was the event actually where my call was not really authenticated or encrypted. So here, at this point, interception attack is possible. And there is a difference variation between the dates I try to make a call. So you see, all these settings changed for a single operator. So these are all my data in last 3 days. And you see that it's never frequent, actually. Of course, it changes. And of course, you can claim that, okay, nobody can make an attack on this point, but it just gives some indicator what is there or what is not there. So what is this radio event is possible? Now, all these events which I'm showing you are after making a call or receiving a call. Now, think of the tool I told you from Israeli company, which compromised your tool, or maybe there are some leaked documents show you that somebody can install a SIM toolkit on your SIM card and can silently send data to a third party without user knowing. Of course, this feature has to have some radio event. There has to have some message which is going through a baseband, right? And this tool gives us a feature that we can trace that without user making a call or without user sending SMS, is there any outgoing communication happening through radio baseband? So actually we try to detect in the baseband log. Of course, it's only work for Intel baseband. So that's why every radio event which is made by user, which is not made by user. So we could do that actually. So this gives you a feature, and we do alert whether this was a call made by you or maybe something else which tried to send SMS or something like that. Then 3G indicators, like you see that, of course, 3G, you say that 3G is pretty much secure. Everybody does mutual authentication, so authentication has been done. Encryption, they were not using encryption, fine, because you cannot do man-in-the-middle attack for 3G. But it's not true. If you have a femtocell, you can do man-in-the-middle attack. So it shows that operator once, for the incoming SMS, operator did not do authentication, did not do encryption, but it did authentication, all those things. And it also shows that for 3G, it was using a UEA1, which is the advanced version of Kusumi algorithm, and it was using. So all these parameters you see in the log. If you click on these logs, you see all these parameters right away. So let's show you the real log. So as you see now, so app gives you a different option. So I try to refresh a log. Now you see here, last column is I didn't make any call. So I try to make one call, and let's see what it really shows for a network. So I try to call myself for my number. And as I said, it has a 1 minute log. So I have to wait 1 minute to create a log to just pop up in my app. So of course, line is busy because I'm calling myself. I go on our app, I just try to refresh. So it will pop up log as it is. So basically, if you see the old log, so this was also when I was testing, this was on a T-Mobile. You see this is a green symbol for the outgoing call, and the encryption, it says yellow. So why it says, so I try to refresh. So it will come up, I will show you, but before that I can show you this one. So I don't know, you see clearly. So the T-Mobile is using A51 encryption, which I lastly made a call. So, and it was doing authentication, then all the parameters you see there. So A51, we know that it's not that secure, it has not been upgraded, but it tells you. The interesting, not yet. Anyway, I try to club it with them, so far it will come back. I will try to go with the next demo, I will show you. So the next point is detecting about silent SMS. So this was essential, or one of the key features while I was trying to do some research. So these are the type 0 messages, which are defined by the GSM 0.340 standard. And the standard says mobiles must acknowledge receipt of these silent SMS, but may discard its contents. So what it really means actually. So if you receive a silent SMS, it will process by your handset, but never notifies to the user. You never get anything in your inbox saying that you received SMS. But after receiving the SMS, handsets inform to the operator, hey, I'm here, I'm at this location, and it does location update. And due to this, you try to see you are at this point. So mobile do not display any notification. And this is the tool useful for the police and other illegal agencies. So in fact, in Germany, in the parliament, they disclosed that in Berlin police, they use 450K silent SMS in a year to track somebody. So of course, they had to release this data. So every government tried to use for their own purpose this kind of silent SMS. But originally, these were designed for the testing purpose, if I'm correct. The tool which I used to test the silent SMS was a Hush SMS tool you can download from Silent Services, which is developed by the German guy. The reference is there. So for the demo, there are two types of Hush SMS allowed or modified for the ease purpose, which is called a ping 3, which is 0-byte WAC push SMS. The second is ping 4, empty MMSN, which I try to send now and will show you a demo how it detects. So it detects after 1 minute, when as soon as you receive, you get a notification pop-up, like you see on the right side, that you have received a silent SMS, and this looks like suspicious because this is not coming from your operator, and you also see the sender's number. Now, after seeing the sender numbers, you can try to Google whether this belongs to operator or maybe somebody has else received this or not. So this is key parameter to identify whether this was some binary SMS received by your operator for a SIM settings or maybe something else. Because we also adding a feature to detect binary SMS, which are processed by, for example, your SIM card only. And as soon as received, we have also enabled options so you can enable the airplane mode. If you feel that, okay, I don't know why I'm getting this SMS often, so you can enable the airplane mode so that you never receive anything. But this feature is not really helpful because we are a passive. We don't control baseband or we don't try to stop it. So not useful, but this is just a feature we add because we never in control of a baseband to do anything or to stop the silent SMS. It's just alerts, nothing else more than that. So let's see the demo for silent SMS. For legal issues, or maybe we wanted to try with the two phones, but some people advise me not to do with other phones. So you see, so this was a log created on 7th August, the last time I made a call. So it was same thing. It was authenticated and it was a green one. Now I try to send silent SMS. Oh, sorry. So I'm back here. I got a call something. So as I said, I'm using a tool. You can also download and try to. So this is the send ping SMS. I try to myself. So this is my number. So don't note it and send any spam, but just. So I try to send 2 messages because what happens sometimes base station, because this is the type 0 message, so it looks like a binary SMS. So sometimes they reject, or sometimes it receives late. So that's why I'm sending 2, just to show you that it works. Because so I send 3 SMS. So hopefully you should get some notification right away that you received a silent SMS. So it says message is sent now. And I noticed that when I was testing here, I had to send 5-6 messages, and sometimes it used to get delivered differently because I'm using my German SIM card. So sometimes if the network is not available for T-Mobile, I was used to go to AT&T by default. So sometimes it takes time to come the message. So I just try to check again, sending just 2 more because sometimes it doesn't arrive. So you should get the pop-up message somehow. So it sends sent again. Yeah, so something is pop-up which shows silent SMS has been received. So you see the notification. I try to open that one. It tells me, looks like there is some suspicious activity. Do you really want to turn off your airplane mode, inactive mode or not? So it just gives the feature. You go to the home, you see in the log, click on this feature, it tells you, so right now it detects 3. So the last log, it had a 3 silent SMS which has been received. This is my phone number, 49160, which I sent. It tells me right away, and it also tells me the date timestamp when I received. The timestamp right now is not working because it was set as a GMT, so don't consider right now as this one. So this is the demo for silent SMS. So this was one of the features for the tool. Next is IMSI catcher detection. So this was a trivial, so because this is the cats and mouse game actually. If you know really, sorry. So IMSI catcher, so this was one more parameter which I'm still trying to find out the main things. So to IMSI catchers, you see this Android IMSI catcher project is working. They try to collect different parameters, how you can say that whether you are a victim of IMSI catchers. Finding parameters, the key parameters to show you that whether you are a victim of IMSI catcher is really essential part. Only doing a location area LAC or cell ID is not enough. For example, Google also provide you some API which you can access, which are the current location area code or what are the cell ID, all these parameters. But those are not really enough. Why? So this was a manual from Gamma company for 3G and GSM IMSI catchers. If you look at their features, I tried to compile whatever the data I got from internet about different IMSI catcher product. There are some leak manual available. So this says, whenever they put any IMSI catcher in a working phase, the first mode it has to always do, which is the scanning. It means it scans all the surrounding base stations in the area and try to find their parameters to tune their own base station for man-in-the-middle attack. So, and second is they jam. They completely jam the surrounding towers by setting some configurations. Of course, they have powerful jammers, not the Chinese jammers you can buy for $5. It will jam everything, not precisely some cell. So it has to be powerful jammer. So it jams all the 3G signals, so your phone never see any 3G signals and automatically come back to GSM. If it comes back to GSM, it means it's coming to their base station so that they can intercept you right away. And they can downgrade. So there is no 3G now, let's use 2G. And they already compile their base station to act as a T-Mobile. So maybe you are the victim who is using a T-Mobile or AT&T. They set their all parameters with this one. So these are not the essential things to do that. So that was, we're trying to find the parameters. So how do I find the parameters? So when we look at the logs, what we see from our app, one thing is we saw pretty interesting, which is called system information type 3 messages. These are the layer 3 messages sent by your base station to the mobile phone, which tells what is the current configuration on the GSM base station. And every operator sends, this is the standard. Every mobile phone sees this message. So what is inside those messages? First is about control channel description. So in that, there are some features. One feature is called MSCR. This means it shows the current GSM network version. What is the software which is running on MSC of that operator, which is serving you the network. So 0, if the byte is 0, it means that it is a release version 98, or when it means MS release version 99. Of course, this is not the unique parameter. But as an end user, if you are going only to the office to workplace and coming back, you always have the same parameters because these are the settings never changed by operator because this comes with the default software. You don't change many things. So between last 3 and 4 months, whenever I travel or I collected the logs, so these bits has been varied between different operators. So Telecom in Germany has the same 99 onwards. So they set the bit as 1. O2 in Germany also same. Vodafone same. Play Network in Poland was using a 98. I don't know why. The BSNL was 99, and OpenBTS or a GS or OpenBSC, which are the open source software protocol stack actually, and many IMSI catchers, I don't know what they kind of software uses. So that's why we need more data to see some parameters. So I don't know how many IMSI catcher manufacturers use the open source tool to modify their equipments to act as IMSI catchers. So by default, this bit has been set as this one. Now, if I tell you these are the bits, of course, these manufacturers will change those bits right away and modify accordingly that. So that's what I said, it's a cats and mouse game, but that's why we need to collect more data about different operators or maybe at least in a single city. So I just need to collect every base station, how it has been configured, what kind of different software versions, what are the different parameters we try to see. The second is radio link timeout. This is also pretty essential, and actually it varies between a different operator. I'm damn sure that IMSI catcher never cares about these fine-tuned parameters. This is my gut feeling, but I don't know. So this is the counter value to just the downlink failure. Basically, this is the thing actually you configure if you have a really huge traffic on your base station. So for example, if this is a New York City and the base station sees more mobile phone user as compared with maybe a tiny village, the settings has to be fine-tuned. For example, if you see this BSNL, which has a 20, because the lower the value, the radio link failure will be less. The call drops will be pretty less actually. If you have a huge traffic, they set the lower value. So BSNL in India, we find out this setting as a 20, Play network in Poland has a 64. Vodafone also has a 64, but that was in Berlin. But I checked Vodafone in London, actually, they really had a different settings. So it varies. O2 in Germany has a 24, so maybe in that area where I was captured, the setting was 24 for the call drop. So like these kind of different settings we can collect. The third was a PWRC, which is the power control indicator, which asks the mobile phone to scan the power measurements for a different surrounding base stations. So this bit has set yes or no. So these are the fine details actually we try to capture with this app in our database. So it automatically scans more than all the parameters and try to record. So this was one more bit. Now, and then we try to build a profile on these fine-tuned parameters. So you never moved out of Las Vegas, for example, and some of the bits are changing, which shouldn't change actually. And then we inform, hey, looks like something is wrong and you haven't moved today anywhere else. So this kind of, we try to build a profile based on your office work city. So this kind of, and we try to, so this is work in progress to build a unique profile. Like you can set your own profile, like I'm not going anywhere, so this is for a single city or single area. You can fix this and it just record. So this is the Las Vegas and all the parameters it record as a profile. So this is work in progress. And you see that here the logs, we collect all these fine-tuned parameters in the log. I just enable this one, but in database there are some hidden values. You can of course export the database and see what are the fine-tuned parameters we are detecting. The last thing is about this tool, which we're not going to release, is about IMSI catcher. So this tool, or I can turn this mobile itself as an IMSI catcher. How? Only first part of IMSI catcher. IMSI catcher intentions are two purposes. First is try to locate some user and intercept. So I'm not doing intercepting anybody, but there is a chance to locate somebody. So one goal, and your phone can act like that. Actually, every phone act like that. I try to explain in a simple word. I'm not going to release all this stuff. So basically, GSM paging requests which are sent on CCCH channel, every base station try to page you when you get a call. For example, somebody is calling you, the base station has to send you a paging message telling, hey, this is the TIMSI number which is getting a call. Is it here? And it just broadcasts the message on a channel to everybody. Actually, his mobile phone can also see a TIMSI of other guy, because he has to verify whether this belongs to me, whether this message belongs to me. This is simple, like Ethernet packet comes, it tries to identify whether this is my IP or not. It's the same kind of principle. So every mobile phone sees this other identifiers. So and to improve the efficiency, all the base stations club 3-4 identities, combining a TIMSI and IMSI in a single paging request and sends to the mobile phone. So mobile phone sees in a single message 4 identifiers or maybe more than that. So paging type 1, paging type 2, paging type 3, different paging types, which can contain 2 mobile identities, 2 or 3 or 4. And just to give a brief example, for example, these are the 2 mobile phones. This is the one mobile phone has an IMSI number, this one, and this guy is turning his mobile phone right now, for example, and this is the other mobile phone which has a TIMSI, this one, and these both parties are getting a call right now. What happens? The base station compiles this into a paging request type 2, because this belongs to 2 mobile users. It combines all the TIMSIs and sends over the air, just a broadcast message. And this is my tool actually, which sees both of the identities. I see the IMSI of other guy, I also see the TIMSI of this other mobile phone. Now you can say, how can I really verify whether this belongs to him? Simple thing. I already told you, many people use silent SMS, right? What I need to do now, I need to send this guy 10 silent SMS. What happens? He'd never get any notification, right? But 10 times he's getting paged, like he's getting some call or SMS. So 10 times his TIMSI will be sent over the air. And in my database or in my tool, I completely see 10 times single TIMSI number has been requested in a 2 minutes time frame. I can see, oh, okay, I'm calling this guy because I know his number, and I see that here, he's in this area of a base station. And this is one part, because if you Google, there are some IMSI catchers, like a tiny, which are specially designed to locate somebody. Because they never interference with the base station, or they never modify the base station setting. They just passively, also actively, but main goal is try to locate you or something. So this can be act as this parameter. And of course, every mobile phone Samsung, I mean, your iPhone or any mobile phone acts in the same fashion. This is a standard. This works in the same fashion. If you tweak something, it works like this. Of course, you don't have access to baseband to do more than that. Of course, I lose some messages. I don't get every paging request sent by a base station. Not every, some of them. That's what you need to be pretty precise, the attack you wanted to make with this one. Now, the same questions, can I trace something? So this is the log, actually, I'm trying to show you. So this was the IMSI we captured in Finland. So this is the track record from Finland. So actually, I wanted to really show you the cool demo here with try to send 10 silent SMS to this guy using his phone number, and I could have shown you his IMSI number right away. But due to some legal issues, I can't do this demo here because this is not allowed to intercept somebody's IMSI and TIMSI here in the United States. So this is the trace from old stuff. So what is the future? So we will release the source code for this app. The app will be also released, but we know the limitation right now, it only works on Intel baseband chipsets, and right now it's only support 2 devices, S3. The best far support is S3 because S2 has some limitations, and it doesn't work that efficiently on S2 because then other apps you cannot really use purposefully. And on S3, it doesn't drain battery that lot. I mean, if you compare with the Facebook, we use much less battery than Facebook. So this is pretty efficient on the battery performance. We also going to provide you data upload functionality. If you use this tool just to play around, feel free to upload the data on a provided server so that we can have a huge database about the different base stations, and we try to collect more information. What are the different operators? Of course, we have a GSM map by SR Labs, but we only see the funky colors, but we don't have a real data. We can't see the real data of different operator, what they have a setting, but you cannot really, by looking at the picture, it's not good. And we try to build more profiles for IMSI cache detection. More than that, what exactly we see, because there are more certain parameters to see from the messages what we see from the baseband. Of course, we're going to collect all this data and share whatever we get because we collect all the anonymous data from this tool. So thank you very much for your attention.